Fundamental concepts, exponents, rules, examples. Exercise. Simplify the following given expressions. Express answers with positive exponents only and no zero exponents. So for the first example, we have 15 s to the 7 times s. Because same bases are being multiplied, using the multiplication rule, we will add the exponents. So we'll say 15 s to the power of 7 plus 1, which will give us then 15 s to the power of 8. For the second example then, we have 7t divided by 7t cubed. Again, same bases are being divided. We will subtract the exponents. So we can say 7t to the power of 1 minus 7, 1 minus 3, which will then give us 7t to the power of negative 2. Now remember, we don't want negative exponents as the final answer. So using the negative exponent rule, we can bring the negative 2 down, so t to the power of negative 2 down, and our result will end up being 7 over t square. So we will get 7 divided by t to the power of 2. For the third example then, alternatively for this one more thing you could have done is we can subtract the exponents in the denominator. We could have directly said something like this, or we can say 7 over t to the power of 3 minus 1. We could have said 7 over t to the power of 3 minus 1, which then will give us 7 over t square. For this one then, applying 4 inside the bracket, we have to be careful here that the negative and 3 is not impacted by 5, because 5 is only on v. The 4 will be impacting negative 3 and v to the 5, all of them. So negative 3 to the power of 4 will end up giving us 81, and for v, because there is one base, 2 exponents on top of it, the exponents will get multiplied, so 5 times 4. So the result will be 81 v to the power of 20. For d then, if you compare c and d, they look same, negative 3, v to the power of 4 and 5, 5 and 4. But because of the difference of the order here, the 5 will make the negative stay negative. Here the 4 made negative became positive. So we will get negative, and then 3 to the power of 5 will end up giving us, we can simplify it, or we can leave it as 3 to the power of 5, and then we get v to the power of 20. Okay, so we do get v to the power of 20, v to the power of 20. Only difference is the number here. This one was positive, this one is a negative, and 3 to the power of 5 will be basically, if you were to simplify further, it will be negative 243 v to the power of 20. Okay. For this one then, we were looking at the zero exponent rule, where anything to the exponent 0 will be 1. So this entire thing will be 1. However, some of us get tricked here. Negative will make it positive. But that's not true. Using order of operations, we have to simplify this part right here first. That will be 1. The highlighted part will be 1. And there is a negative in front. So answer for this one will be a negative 1. For the next one then, again 1 base 2 exponents. We will multiply the exponents. So we will get negative r to the power of negative 10. Which then further simplify to, we don't want final answer to have negative exponents. So we will simplify this further as negative 1 over r to the power of 10. Okay. For this one then, it looks like, oh, 3m to the negative 4, 3m to the negative 4. But the difference is the bracket. In the numerator, negative 4 applies to 3m altogether. In the denominator, negative 4 only applies to 4. So for this question, you can take different approaches. One being, let's bring this negative 4 inside the bracket first, apply it to 3, apply it to 4, and go from there. So I'm going to say this will be same as, in the numerator, I will have 3 to the power of negative 4 times m to the power of negative 4 divided by this. Now if you notice 3 to the negative 4, m to the negative 4, m to the negative 4, we can reduce those two. We end up getting 3 to the power of negative 4, and in the denominator these two reduces, so they both cancel out basically. We end up getting 3 to the power of negative 4 minus 1. Same base is being divided, we subtract the exponents, so 3 to the power of negative 4 minus 1 will give us 3 to the power of negative 5. Again, we do not want final answers to have a negative exponent or zero exponent. So what we can do is now bring this 3 to the power of negative 5 down to make it positive exponent, and we can write our final answer as 1 over 3 to the power of 5. Okay. Which you can, if you like, you can leave it like that, or you can simplify it to be 1 over 243. That would be your answer to that particular example. Next one then, we have, it looks like we have some bunch of x's and y's with some exponents. So again, we have to be careful. If the bracket is there, the exponent outside applies to everything. If there is no bracket, it only applies to that particular variable. So x remains x. Y to the negative 3 we have, so x times y to the negative 3. The square for the second part, if I brought that in, the negative sign will become positive, negative square will be a positive, times x to the power of negative 2 times 2 will be negative 4, and y to the power of 1 times 2 will be 2. Now, same base is being multiplied, we'll add the exponents. So I have x to the power of 1 plus negative 4, and for the y we have negative 3 plus 1 plus 2, which then ends up being x to the power of negative 3, y to the power of negative 1. Okay. Simplifying this further, again, our final answer cannot have negative exponents. So simplifying this further, we can write our final answer like this. We can say it will be basically 1 over x to the positive 3, y to the positive 1. Because x and y both have negative exponents, we will bring both of them down to make it positive exponents. If for some reason, let's say we had x to the power of positive 3, then x to the power of positive 3 would have stayed in the numerator. Only y to the negative 1 would have come down. Okay. Combining all of the rules, the trickiest it gets is something like this I have some numbers, some variables, some negative exponents. Outside the bracket, there is a negative exponent. So for this question, we have few options to do. Option 1, what you can do is, for first option, what you can do is basically get rid of negative exponent outside the bracket. Another option you have is work within the bracket and then take care of the negative exponent outside the bracket. So I'm going to take the second approach. I'm going to take care of whatever is inside the bracket, see how we can simplify that. So 9 and 6 both will reduce by 3, and we will end up getting 3 here, and the 6 will become 2. Now for the x's and y's and z's, if you have negative exponents, you have two options. Either deal with negative exponents at the end, or get rid of negative exponents first by bringing negative exponents from the numerator into the denominator, and negative exponents from the denominator to bring it in the numerator. So I am going to say y to the negative 2, z to the negative 5, they both will go down and become positive exponents. Similarly, x to the negative 3 will go up and become positive exponent. So this is what we end up getting. X to the 3 in the numerator stays there. X to the negative 3 in the denominator goes up to become positive exponent. So this one went up and it became positive exponent. So this right here is gone. Okay. For the y to the negative 2 from the numerator, it is going to come down in the denominator and become y to the positive 2. Denominator also already have another y to the positive 2, so it will stay there. Okay. And for the z to the negative 5, one thing to notice is both are z to the negative 5, we can reduce it. Or let's just switch their position for now. Y to the negative 5 from the denominator will go in the numerator, become, z to the negative 5 going in the numerator will become z to the positive 5. Z to the negative 5 in the numerator going down will become positive z to the 5. So I got rid of negative exponents by switching from numerator to denominator, denominator to the numerator. Now what I can do is use subtraction and addition of exponents, basically product and multiplication rule, to simplify this further to look like this. The 3 and 2 will remain same. X to the 3 plus 3 will give me x to the 6. Z to the 5 and being divided by another z to the 5, so same basis being divided, we subtract the exponents, so this is gone. And in the denominator, y square and y square being multiplied, I can add their exponents. Now simplifying this little bit more, we get z to the 5 minus 5, which is z to the power of 0. Okay, and we know anything to the power of 0 will end up being 1. In the denominator, we have y to the 2 plus 2, which will be 4. So this 6 I got by doing 3 plus 3. So I'll keep 3 plus 3 here. Now, last step then, or second last step I should say, this negative 2, if I want to get rid of it, I have two options again. I bring that negative 2 in and apply negative to everything. However, that way I'll get another negative exponents. So instead of doing that, what else I can do is, if I want to get rid of negative exponent outside the bracket, I can switch my numerator and denominator, meaning that I flip it. Numerator will become denominator, denominator will become numerator. No change. Everything else exactly same. Just numerator becomes denominator, denominator will become numerator. Okay. And then the negative 2 in the exponent, negative 2 in the exponent will become positive. Okay. And lastly, now bring the square in. Our final answer will look like, square inside the bracket. So 2 square will give us 4. 2 square will give us 4. Y square will give us, y to the 4 square will give us 4 times 2, which is 8. 3 square will give us 9. X to the 6 times 2 will give us 12 there in the exponent. And z to the 0 times 2 will be z to the power of 0, which is basically 1. So if you notice, I don't have z anymore because I get z to the power of 1, which will end up being 1. So this will be our final answer. This is not only one way to do it. You might use different exponent rules at different time than I did and still end up with same result as far as you don't make mistake.